Hello and welcome to your second pre-calculus video. This is still 1.1, but we are now in part 2. We are going to be going over pages 6 and 8. So that's what we'll be focusing on. Starting on page 6 with example 5, it's day 2. Let's get into some story problems. So as we go through the examples, I'm going to go through and highlight what I think the important parts are, just so we can focus on that. So let me get my highlighter out. It's already on yellow. So let's see, P of t is the population of a country in millions after January 1st, 2000. The function p is defined as what is written below here. And then we have n of t is the number of people the country can feed t years after January 1st, 2000. And n of t is defined as such. So you'll notice I also like to color code my information, so I'm going to do that to the best of my ability. So when we take a look at the first problem, it says one way to measure prosperity is to measure surplus. So we are looking at populations, but the first one is just overall population, while the second one is population the country can actually feed. So we're going to say that surplus, or S of t, is n of t minus p of t. So if you remember back to our last video, we are now just using operations of functions. We are subtracting the two functions. So let's actually find S of t. So we'll say that S of t is equal to n of t minus p of t. So let's plug that in. Let's see, n of t is 4 plus 0.5 t. And you'll notice I try to make my t's a little curvy so they look different than my plus signs. But if you get confused, please let me know. Let's see, minus 0.01 t squared plus 2. And the reason that I've put p of t in parentheses is because we need to take this negative sign and distribute it. Many people forget to do that, so please do not forget. But we end up with 4 plus 0.5 t minus 0.01 t squared minus 2. We're going to combine our like terms, that 4 and that 2. So we get 2 plus 0.5 t minus 0.01 t squared. Now, this next step that I'm going to do, it's not technically mathematical, but when we are writing out polynomials or something with different powers, we always write it from the highest power to the lowest power. So this next step I'm going to do is really just a rearrangement. So I'm not changing the mathematical value of anything. I'm just putting this in order from the greatest to the smallest power. So this will be negative 0.01 t squared plus 0.5 t plus 2. So this is the equation that we will be using for S of t. And the next two parts, B and C, ask us to evaluate and interpret. So whenever it says evaluate, where's my highlighter? Whenever it says evaluate, that means we're going to plug something in. So in this case, 45. And whenever it says interpret, I want you to write a sentence. Because numbers are just numbers until they mean something. And since this is a story problem, I want us to put our answer or our number into a context. So for each of these, we're going to plug something in and write a sentence about it. So let's get started. So the first thing we're plugging in is 45. Let's see, S of 45 is going to be a negative 0.01 t. Oop, it's not t anymore. There we go. 45 squared plus 0.5 times 45 plus 2. Let's simplify how we can. I'm hoping that you have a calculator with you. For right now, you can use either a scientific or a graphing. Later on, when we actually work on graphing, I will ask that you only use a scientific. So let's see if we plug this in. That's going to be negative 0.01 times 2025. Just a reminder, order of operations, exponent comes before multiplication. Let's see, this becomes 22.5 plus 2. This becomes negative 20.25 plus 22.5 plus 2, giving us an answer of 4.25. So this is kind of the algebra piece of the problem. But the real question is, what is 4.25? What does that mean? Well, we have to go back to what is this equation of S? And S is the surplus of what we have, surplus of our number of people we can feed. So we're looking at the total population. We can feed this many people extra, but we're not feeding 4.25 people extra because we're not going to have part of a person. If you go back to the problem, you'll notice, oops, that is not what I wanted to do. There we go. You'll notice it is in millions, so it's 4.25 million people. So using those units is going to be very important when we write our sentence. Let's do it in green. So our sentence, and remember, so the number we're plugging in is years after January 1st, 2000. So we'll write 45 years after January 1st, 2000. Oops, I don't know what I just clicked. There we go. So I'm mentioning my input. So with this input, we get the output that the country, doesn't say exactly which country, can feed a surplus, since that is what we were looking at, of 4.25 million people. Now, your sentence might look slightly different. You might say that the country can feed a surplus of 4.25 million people in 2045, and that is also an acceptable answer. It all means the same thing. So as long as you have the same information, if your sentence looks slightly different than mine, that's totally fine. Let's try the next problem, where we're going to do the same thing. We're going to evaluate, except now it is 55 years after January 1st, 2000, and then we're also going to write another sentence. So let's see, this will be S of 55, and yes, my S's and my 5's look almost exactly the same. I'm going to try to make sure that you can differentiate. Let's see. Let's take our S equation and plug in or evaluate with 55. So it should look something like this. And then from here, let's use our order of operations and solve. We have to square first. So this becomes a number known as 3025 plus 0.05 times 55, which is 27.5 plus 2. Let's use our multiplication skills and get negative 30.25 plus 27.5 plus 2. Now when we finally add all of these together, we get negative 0.75. So here's the problem. We're talking about surplus, which is what S of t stands for, but we end up with negative numbers. So we have to think in the context of the story. We're not going to say they can feed a surplus of a negative amount of people. That doesn't really make sense. So if I think about the story, we're talking about how many people we can feed. So if we have a surplus that's negative, it means those people will have to go without food or will be hungry. Now, normally it means that they will just have less food, but in this case, we're going to say we feed everyone until there's a full belly, and then there's no one else. I'm sorry if you heard that buzz, I just got a text message. So, in a sentence, if I don't feel like saying 55 years after January 1st, 2000, I might just say, in the year 2055, because that means the same thing. Instead of writing negative 0.75, I'm just going to say 0.75 million people will go hungry in this country. So even though my algebraic answer has a negative, I took the negative out of the sentence and changed the sentence so it reflected the context of what that negative really means, which is why I want you writing sentences for story problems and really showing me that you understand what these numbers mean. That was all the story problems we have today. we're about to move on to page 8. Here we are, page 8, example 6. We're only going to be doing half of this page. We are going to save group work 2 until tomorrow. So this is our last example with A, B, and C. So now instead of operations of functions, we're going to be plugging things into different functions or manipulating them in certain ways. So for instance, part A says f of x plus 2. So I'm going to take the entirety of f of x and just add 2 to it. So it's going to look like, oop, my pen was on yellow. There we go. So I take this, this will be all of my f of x, so 5x squared plus 3x plus 4. Ooh, it's running into the other thing. And I'm going to add 2 to that. So this becomes 5x squared plus 3x plus 6. And that is my answer. Yay! That was kind of it. So let's try that with part B. First, I am going to separate these sections. Ooh, that's real squiggly. Okay, so for part B, that's f of x plus 2. So the plus 2 is no longer on the outside, which means wherever we see an x in our f of x equation, instead of just an x, we're going to put it in an f of x, or we're going to put it in an x plus 2. So that's going to look like f of x plus 2 squared, since we're plugging this in wherever we see an x, plus 3 times x plus 2, plus 4. Now, since we have to square x plus 2, we're taking a look over here. We have to square this. There are many different methods you can use, and I just want you to use whatever you feel most comfortable with. With some people, that may be box method, so x plus 2 and x plus 2, where you multiply each of those together. So x plus x, or pardon me, x times x would be x squared, 2 times x would be a positive 2x, 2 times x would be a positive 2x, and 2 times 2 would be a positive 4, and add all of those together. Or you can use your FOIL method of x plus 2 times x plus 2, and do your first, outer, inner, last, multiply all those together, and add those up. I'm not going to, you've kind of seen the different methods you can do here. You can also, if you can do it in your head, feel free to do it in your head. But I'm going to let you know that that is actually going to be x squared plus 4x plus 4 should be your answer. And now I'm going to take this 3 right here, distribute that so that this becomes plus 3x plus 6. We still have that plus 4 at the end. I'm going to take this 5 at the beginning and multiply to all of this stuff. So many, okay. And we end up with 5x squared plus 20x plus 20 plus 3x plus 6 plus 4. So I've expanded this as much as I possibly can, and now I'm going to combine my like terms. So this is going to give us a 5x squared. So 20x plus 3x is going to give us a positive 23x. And then we have a 20 plus 6 plus 4, or 30. So this right here is our final answer. So some of these may take longer than others, and that's okay. So for our last one, which I'm going to be doing all the way over here, this is going to be part C, is f of x plus 2 minus f of x. So kind of the nice thing here is we can go through and resolve for f of x plus 2, but we kind of just did that. So I'm okay if you just reuse that over here. So if we're doing f of x plus 2, oops, that should be inside the parentheses. There we go. Plus 2 minus f of x. I'm also going to shift this over a bit. It's going to look like 5x squared plus 23x plus 30. We've already found that. We just did that in our previous answer. Minus, ooh, I'm going to run out of space. 5x squared plus 3x plus 4. Yep, kind of ran out of space. So now that I have that, I'm going to do what I can with distributing this negative. We did that on our previous page. and end up with 5x squared. I'm going to try to write this a little smaller. 5x squared plus 23x plus 30 minus 5x squared minus 3x minus 4. So again, please make sure you are distributing your negative throughout. Once we've done that, we can combine like terms. We have a 5x squared and a negative 5x squared, so that goes away. We have a 23x minus a 3x. We end up with 20x. And we have a 30 minus 4, leaving us with a positive 26. So this is our answer. So we're just spending time manipulating our functions and evaluating them with various inputs. So take some time, feel free to rewatch this video. We'll go over group work 2 tomorrow in class. I look forward to seeing you.